See the second problem. Solve the difference equation mu n plus 2 minus 3 mu n plus 1 plus 2 mu n is equal to 0 using Z transforms. Given that mu naught is equal to 0, mu 1 is equal to 0. What is the difference between the second problem and first problem? In first problem we have yn plus 1 yn like that. So in place of y you have mu. మనల్ని కన్ఫ్యూజ్ చేయడానికి అలా చేస్తారు. సో y ప్లేస్లో మ్యూ ఉందంతే. ఓకే, సీ ద సొల్యూషన్. ద గివెన్ ఈక్వేషన్ ఈజ్ mu n plus 2 minus 3 into mu n plus 1 plus 2 mu n is equal to 0. Now you let the formula. Z transform of mu n is mu of z. అంటే z transform of yn అని రాసాము ఇందాక, ఇక్కడ mu n. And z transform of mu n plus 1 is equal to z into mu z minus mu naught. Z transform of mu n plus 2 is equal to z square into mu z minus mu naught minus mu n by 2. Now you take the z transform on both sides of given equation, this one. Now you get z transform of mu n plus 2 minus 3 z into mu n plus 1 plus 2 into z transform of mu n is equal to 0. Now substitute this z mu n plus 2 formula here, and also z mu n plus 1 formula as the second term, z mu n as mu z. Now we get z square in place of z mu n plus 1, these terms. This one z square mu of z minus mu naught minus mu 1 by z minus 3 z mu n plus 1 means z mu of z minus mu naught plus 2 mu of z is equal to 0. You get, use the conditions. What are the conditions we have given? Mu naught is equal to 0. Substitute here. Mu naught is equal to 0. Mu n is equal to 1. Mu n is 1 by z here. Similarly, mu naught is equal to 0 here. Substitute the conditions. Using these conditions, it reduces to z square into mu of z minus 0 minus 1 by z minus 3 z mu of z minus 0 plus 2 mu of z is equal to 0. Now what terms, what are the remaining terms? Here z square mu of z minus z square into 1 by z means minus 1 by, ఇక్కడ minus z మిగులుతుంది, minus 3z into mu z plus 2 into mu z. So mu z కామన్ తీస్తే here first term z square minus 3z plus 2. ఇంకేముంది ఇక్కడ z square into minus z means minus z ఉందమ్మా. Then the remaining term z square into minus 1 by z means minus z is equal to 0. Then bring this z into RHS, you get mu of z square minus 3z plus 2 is equal to z. Then mu of z into some value is there. Now it can be written as mu of z is z by z square minus 3z plus 2, which can be written as, make it into partial fractions or factors. It is z minus 1 into z minus 2. Z bring outside, 1 by z minus 1 into z minus 2. After making the partial fractions, you get 1 by z minus 2 minus 1 by z plus 1. This is mu of z. This is mu of z. Now it can be written as z by z minus 2 minus z by z minus 1. Now take the inverse z transform on both sides. We get z inverse u of z is equal to z inverse z by z minus 2 minus z by z minus 1. Now this z inverse mu of z is equal to mu n is equal to z inverse z by z minus 2 minus z inverse z by z minus 1. Already in last problems we seen that z inverse z by z minus a is equal to a power n. In the first one, in place of a we have 2, so it is 2 power n. Similarly, z inverse z by z minus 1 is 1. Now this is the solution of the given difference equation. This is the solution of given difference equation. See the next one. Solve the difference equation using Z transform. yn మళ్ళీ ఇది yn లో ఇచ్చినారు మీ ప్రాబ్లం yn plus 2 minus 4yn plus 1 plus 3yn is equal to 0. Given the conditions y0 is equal to 2 and y1 is equal to 4. Okay, see the solution. The given equation is yn plus 2 minus 4yn plus 1 plus 3yn is equal to 0. This is the given difference equation. Okay, with these conditions y0 is equal to 2, yn is equal to 4. Now you let, as usual in the previous problem, z of yn is y of z, z of yn plus 1 is z into yz minus y0, z of yn plus 2 is equal to z square yz minus y0 minus y1 z inverse. Okay, now let the z transform on both sides to the given de means difference equation. We get z transform of yn plus 2 minus 4 z of yn plus 1 plus 3 z of yn is equal to 0. Now substitute this z of yn plus 2 terms here. Z square of y of z minus y0 minus y1 z inverse minus 4 z of yn plus 1. What is z of yn plus 1? Substitute here. 4 into z into y of z minus y0 plus 3 into what is y of z and z transform of yn is y of z. Okay, now we see the next step. Okay, before reducing, substitute the conditions. After substitution this formulae, next step you substitute the given condition. What are the given conditions? y0 is equal to 2. Substitute here. Y0 is equal to 2. Another y0 is 2 here. And next y1 is equal to 4. Here y1 is there. Substitute y1 4. In the next step, only one y1 is there. So substitute y1 is 4, y0 is equal to 2. Then we get z square into y of z minus 2 minus 4 z inverse minus 4 into z into y of z minus 2 plus 3 y of z is equal to 0. That is y of z common this day, z square y of z is here minus 4z into y of z means minus 4z plus 3y of z plus 3 y of z is common. Y of z, the terms not containing y of z are z square into minus 2 z square into minus 4 into minus z power minus 1 means minus 4 into z. Next minus 4z into minus 2 means plus 8z is equal to 0. Then here y of z into z square minus 4z plus 3 is equal to, now this one equal to, see here 2z square plus 4z. What is the remaining terms ma? Y of z into some value. This is 2z square minus 2z square plus 4z. Bring this side plus 2z square minus 4z. Z common, z into 2z minus 4. Now you write it as y of z into some value z into 2z minus 4. Bring this z to LHS side. Y of z by z is equal to 2z minus 4 into undi. Bring this side. It becomes denominator z square minus 4z plus 3. Now it can be written, reduce the denominator into factors. You get 2z minus 4 by z minus 1 z minus 3. Make it into partial fractions. You get this RHS 1 by z minus 1 plus 1 by z minus 3. Now y of z is cross multiplication z by z minus 1 plus z by z minus 3. Let the inverse transform on both sides. You get z inverse y of z is z inverse z by z minus 1 plus z inverse z by z minus 3. Now you get yn is equal to, this one value is 1 plus, here it is a is 3. This is 1 plus 3 power n is the solution of given equation. Okay ma, thank you.